Thank you, everybody. Thanks for sticking around. Thank you to all the 6,400 people that registered throughout the day and for this particular session on securing the connected factory of tomorrow. I'd like to introduce the moderator, Dr. Bell. The floor is yours.
Hello, everyone. Thank you so much for joining us today. My name is Dr. Natalia Bell, and I am going to be the moderator for the security, the Connected Factory of Tomorrow session here at IIoT World Manufacture Day of 2022. So why this session? Industrial Internet of Things, or IIoT, Industry 4.0, can accelerate and improve the business outcomes, bring immense value to the organizations. However, as anything connected to the internet, the IIoT devices are also subject to cyber threats, including interruption, spoofing of traffic, hijacking of critical connected devices. So these critical IIoT systems require reliable connectivity and ability to trust the data and the devices within the ecosystems in which they are operating. In this session, we will learn how to enable new digital business models with secure communication in the connected factory. So I would like to introduce you the panelists today. So as I said, my name is Dr. Natalia Bell. I'm currently an assistant professor at Marymount University in Arlington, Virginia. And together I have Ellen Boyan, Martin Osko, and Eric Irvin. So I'm going to start with short bibliographies of our panelists today, and then I'm going through the segments of the session. So Ellen Boyan is the SVP of IoT Strategies and Operations at Keyfactor. Ellen is leading the product strategy and go-market approach to Keyfactor Control Platform. The Keyfactor platform is focusing around digital identity solutions, security solutions for IoT devices in the manufacturer market. Ellen is passionate about IoT and helping customers establishing secure implementations for the life cycle of their overall IoT systems. Ellen has more than 15 years of experience leading new products development with a focus on IoT and connected products in lighting controls, smart cities, connected buildings, smart homes technologies. Ellen has held leadership roles in the product and engineering at General Electric and Sky Technologies over her career. Thank you so much, Ellen, for being with us today. Martin Osko. Martin Osko is SVP of Product IME at Keyfactor. Martin is passionate about supporting organizations across the world in their digital journey and using modern security concepts as enabler for new business models. He has more than 20 years of experience in the field of information technology with a strong focus on security. In the past, Martin held various leadership roles in sales and product management for different global players in the IT security arena. During that time, Martin was involved in various IoT, IIoT, and OT projects, industrial, automotive, consumer electronics. And today, Martin is the SVP of Product IME at Keyfactor and Managing Director for the German subsidiary. And last but not least, I have Eric Irvin. Eric is the Director of the Industrial Cybersecurity at 1898 & Co. 1898 & Co. is Portal, Burns, and McDonald, provides strategy, implementation, business outcome solutions, managed security services to help asset owner services to improve safety, security, reliability of their critical infrastructure, improve risk management through the resiliency, and improve situational awareness and preparedness. As the director of the industrial cybersecurity, Eric is leveraging his 21 plus years of experience to deliver solutions and services within the utility and manufacturing sector with concentration for ICS and SCADA systems, cybersecurity program development. He spent 2 decades with large investor-owned Midwest utility and technology, regulatory leadership roles, and has extensive experience in leading strategic technologies initiatives focused on security, critical infrastructure, risk management, compliance implementation, program management, network operation, and physical security. A great honor to be the moderator of today's session. Thank you so much for joining. Just a quick heads up, we're gonna divide the session in 4 segments. In the segment number 1, we're going to talk what is new and what are the current challenges that we're facing. In segment number 2, we'll talk more about the technological part and the tools that we currently have available. In segment number 3, we're going to talk about the solutions. and we'll leave the segment number 4 for questions and answers. So I highly recommend making use of the chat. I'm going to monitor the chat while our panelists are talking, and we're going to address your questions during or after each panelist is talking. Also, I encourage my panelists to react to the chat messages affirmation. So we're gonna be here to answer and make this session as pleasant as possible. So now I would like to move forward with segment number 1. I was myself being in cybersecurity, I'm currently a professor of cybersecurity. One thing that we know for sure is that cybersecurity is a ever-changing field, and the same, all the devices and systems that we currently are connected to the internet are also see those changes. Well, as any change comes with responsibilities and challenges. So I want to ask my panelists here, what are the current challenges that that you see in today's manufacturing? What is the landscape changing in regard to security manufacturing operations? So I would like to start with Eric.
All right, well, thank you, Dr. Bell, and thanks to the audience for joining us today. So historically, SCADA systems, your programmable logic controllers, your human machine interface devices that control, the digital plant, sat on disconnected zones. And so you've heard the term air gapped, that was the common practice for a long time. Today, however, engineering and operations, for example, they're needing up-to-date information from those systems and devices, external connections, say vendor control, for example, supply chain, in order to improve those operational efficiencies. And so we're seeing those types of drivers really change the landscape for manufacturing and specifically within the with the exponential growth of industrial IoT devices, though, ensuring connectivity is essential. So whether those are connected through a mesh network, cellular-based connectivity, there's all sorts of backhaul connectivity that's there to pull these devices together. But within manufacturing, you've got your robotics, process automation, remote controlled machinery, you've got shipping and logistics, predictive maintenance, which is really, picking up a lot of traction too. So you're not doing time-based maintenance, for example. You can actually get to a little more informed, data-driven maintenance schedule. And so a great deal of this IoT used for automation and factory settings involves collecting data about the physical environment and acting on that data. And that's where engineering and operations really sees the benefit from IoT in automation 4.0, for example. This results in the plant increasing managed remote that's capable of a level of autonomous operation, error correction, self-reporting of functions, that type of thing that really help operations, again, run the plant more efficiently.
Thank you so much, Eric. Ellen, what is new? What is challenging?
Yeah, I think I completely agree with everything Eric said. And to add to that, I think other priorities involve keeping factory uptime, at top of mind as well, because we're adding in additional capabilities and these smart monitoring and diagnostic types of things, but there is still the utmost importance of production and putting out however many parts per hour are needed, because all of that kind of hits the bottom line when it comes to the operation. So equipment needs to be highly available, needs to be reliable, even as we're adding this layer now of software and connectivity into some of these things that are connecting to our traditionally non-connected control systems. So I think that that's another thing to think about, is that there's benefits that we gain by making some of these things more connected, but we have to also consider that we can't be disrupting the normal flow of production, and just because that really also then can add cost, customer dissatisfaction, or just undue stress, I think, in the shop operations.
Okay, thank you so much. Martin?
Yeah, as addition to that, what Eric and Ellen said, I think we see also another sort of a new trend in functionality and the way how specifically in factories machines are produced, and this call it the software-defined everything. So there's more and more functionality that comes as software and basically replaces old style, partially PCBs or some PLC systems. And with that, I mean, of course, this brings a lot of new opportunities to the market. You can change your business model, moving away from selling a very expensive machine for different purposes, instead of having one which can do everything, and you have to basically pay per function. However, this comes, of course, with a challenge that the more software is involved and the more connectivity is important, the more important the security aspects becomes. And this is for many vendors a new game. I mean, if you think about this, machinery manufacturers, they are excellent in producing the machines, and the software aspect was mostly focused on steering and controls, and the security game is new. And I think what we will need more and more in the future are security concepts which are easy to understand and adopt by maybe not by specialists within the machinery market, but not necessarily IT security specialists.
Thank you so much, all of you. And we talked about the benefits of going towards automatic processes, right? Well, but this also involves risks. So my second question to all of you, and maybe we can start with Eric again, is what are the risks that are involved in moving to this advanced automation processes in the manufacturing world? So Eric, what do you think?
Yeah, that's a great question, Dr. Bell. And, there's so many benefits to, growing, your IoT devices and moving forward with an automation, direction. That said, there's a tremendous amount of capital investment going on in the manufacturing automation space right now. And this is, as a result of numerous technology projects running in parallel, sometimes leaving a fractured approach, in securing that automation, in manufacturing floors. So some of the more common vulnerabilities, or attack strategies against, such as denial of service, man in the middle, masquerading attacks. Those are some of the more common, but we're seeing unencrypted communications just because of the sheer number of devices that are being deployed and how quickly they're and how easy they are to deploy. So we're seeing an unencrypted communication at times. We're seeing devices scattered across a large geographic area, which further, increases that attack surface from a cybersecurity standpoint. Devices often share information with control systems, as business intelligence and big data really come into play for make smarter, more informed decisions, more timely decisions. That type of risk is there. So in addition, I was reading up on a couple different articles too, and CISA, the Cybersecurity and Infrastructure Security Agency, recently warned that in addition to greater efficiency, increased automation in the manufacturing sector will also bring greater digital risk that malicious hackers can exploit. And so I think we all recognize that it's like the next step is, okay, now what do we do now that we know this digital transformation is occurring and there's extreme value to pursuing that?
Yeah, interesting that you mentioned that. As a matter of fact, CISA is 5 minutes walking from my office. So we are located in a very cybersecurity point. So Martin, what are, in your opinion, the risks associated with this advanced automation, or moving towards that advanced automation processes?
Mm-hmm. I think in general, the complexity of the whole system is growing, and by growing complexity, of course, the risks are, specifically cybersecurity risks are also increasing. Also connecting to that, what I was mentioning before about software-defined solutions, something new which is very often not addressed immediately, and basically there's only a reactive answer to it, is patch management of those systems, which is obviously critical for cybersecurity. On top of that, it is not very natural or maybe intuitive for many of the manufacturers in the world to have the security by design approach. So very often the solution is designed first and then the security is added, which is very often way more expensive comparing that to an initial solution. And things like secure identity, secure communication, patch management, firmware protection, firmware signing, and things like that are not, are only addressed after some actually the issues already occur, and there was already a negative negative effect already in the factory.
Yep. Thank you so much, Ellen.
Yes, I agree with what's been said so far. I think to add to that, another perspective could be the complexities of global manufacturing, right? So typically, there's some combination of your own factories that you own, maybe also leveraging partners, contract manufacturers, third party, that sort of thing. And so how to make sure that between all of those different providers and or partners, that you have a consistent approach from how it works and infrastructure within security on top of that. I think some manufacturers are looking to push more workloads to the cloud. And so that is also a whole nother topic, I think, that how to leverage that, how to be able to trust things in the cloud when everything has traditionally been, in like an on-site, in a cage, in a locked, room, like that sort of mindset, and it's worked, right? But then now there's capabilities to move some of that to leverage some more some digital offerings now. So that's, I think, something else to think about and when you're kind of architecting this together.
Yeah. Well, thank you so much. As a follow-up question, it might be, I might take you surprising. We're talking a lot about cybersecurity or security or information security. However, what differentiates the traditional system security compared to manufacturer security in terms of risks? Do you think that the manufacturing world faces higher risks than regular technological systems? Let's put it this way. Is the manufacturing world maybe more targeted by cyber criminals, and if yes, why?
Well, I can jump in there to start with, but I know, it's been reported that manufacturers, have already been disproportionately targeted by ransomware actors and other cyber criminals during the pandemic. And, as things start to ramp back up, I think that is just going to continue to increase as well. So.
Mm-hmm. Martin?
Yeah, so I think what we see in the manufacturing world in terms of risks is probably the immediate impact on finance. I mean, if a factory is attacked and it goes down, then it immediately costs millions of dollars, which maybe is not the case in a enterprise sector, because this is usually then something around ransomware. And of course, there's some maybe not, the productivity is limited, maybe the people cannot work, but it is not that hard disruption of the production process and of the revenue stream. So I think it's just a question of time till either cyber criminals will focus in this area even more, because there's even more money to get in terms of ransom, but not in terms of okay, we have encrypted your disk drives, but because we basically took over your whole factory.
Yeah, thank you so much, Ellen. Yep.
Yeah, I agree. I think another thought could really be around, we know a lot about how to secure things within the enterprise, right? Whether that's enterprise devices or even just the laptops that we all use for working, passwords, two-factor auth, like that type of thing, are ways that we protect the endpoints that get onto corporate networks. So thinking about in factory environments, what are those devices that are then that open portal to someone be able to hack? And again, those things coming from multiple providers with perhaps different non-standardized way of layering in security, is a weakness. And so I think that that's something that, as you know, people in this space, we have to kind of come together and make sure that we're providing guidance, recommendations, and then have these conversations about how to do this best in this industry.
And we know critical infrastructure is a target, you know,
Yep.
across the world. And so as more and more of these systems are brought online, you know, the broader the attack surface is, you know, is these systems are connected to your, you know, digital physical systems, your operational technology that actually operates the machinery in the field. So.
Yeah. Thank you so much. We have a comment in chat. Thank you so much, Asif. Cyber defense will be the priority for new world order, and ransom activities will be increased as we adapt to new technologies in automation and smart technologies. So yeah, definitely, as you were saying, because it's so attractive to cyber criminals, they orient themselves towards the financial gain or benefit, which makes the cyber threat a real priority for us today. We talked about the challenges, and we talked about what is new as a second part of as a second segment of our discussion. I would like to address what we can do. And specifically in this part, I would like to focus on the technologies and tools that you consider that they are useful in order to overcome those risks and challenges, and not necessarily to eliminate the risks, because this is not necessarily possible, but diminish as much as possible the risks associated with the cyber threats that we currently have. So I'm going to start with Ellen. So Ellen, one of the things that we're mentioning is the code signing, right? The code signing in the industrial IoT space. Why is this important?
Sure. So as a tool, code signing really is the concept of any firmware, right, that is running some sort of control system or device that is being used within the smart factory, is ensuring that code doesn't execute or doesn't run something unless you verify the authenticity of that code. And so we do that by signing it with with a certificate, generally that is known and held, and keys, private keys, kind of underneath that are held in a very secure HSM. So I don't want to go too much in details of that, but just the premise is that you want to make sure that any code that's running your equipment is been authorized to be able to do so. And so we do that by signing the code and then providing some verification. So oftentimes that's used in conjunction with secure booting process. So we don't allow the equipment to actually turn on and run until you've done a verification of that signature, and you can do that every single time. And then secondly is, as you change code and applications that are running on these devices and you need to update and put some new code in there, again, you should not install new code until you've validated that signature. So it's everything from initial application deployment to update ability of that, as well as even just booting up every time. And that's a really, I think, simple way that manufacturers can verify how their machine is actually running, so that you don't get some sort of malware code that then can just turn on and operate your equipment.
Yeah, thank you so much. Martin, anything to add on it? I do have a question for you as well, but
I think this was a great summary, but I think the big question is how me as an operator of a factory, how do I make sure that whenever I upgrade or patch my my infrastructure, the machines actually working as they were supposed to do by the vendor of those machines. Yeah? And because everything's becoming software, so the software-defined functionality, it is the code signing is basically the fundamental way to secure that. And there's probably something even before that, because the question is, how does a machine validate that the code is coming from the right source? Yeah. Is it, do I got my code or the latest upgrade for my robot or the machinery from the vendor, or because of a cyber attack, for instance, someone is trying to get something from basically a manipulated code, which will either disrupt my production or maybe even looking at the supply chain attacks we have seen in the past. I think 2 or 3 years ago, there was an interesting example discovered by Google. And it was not in terms of machinery production, but in terms of electronics, consumer electronics, main boards, PCBs for computers. And there was a big question if there are some parts on the main boards which actually should not be there. And how do I make sure that my production chain does exactly that what it should? And to do so, there's something about code signing, but then there's also something about the ability to validate and the technologies around that. That's the code is from the right source.
Talking about the technology to validate on the cybersecurity side and the regular systems, we leverage a lot the usage of machine learning and artificial intelligence. So now, as a surprise question, in the manufacturing world, would the artificial intelligence, machine learning would help in diminishing the risk or the threats, or in terms of code signing, would that help diminish maybe the cases or the attacks by using some observational or rather like some alerts that can come saying, okay, something is wrong?
Yeah, I think at the end of the day, it will be a mixture of technology, and everything what helps and can reduce the risks is probably something that should be done or at least considered. I mean, usually AI technologies can detect patterns that has been already seen before. That's how AI works. That's basically detection of patterns within network communication, within file structures. So it's in my opinion, it probably still plays an important role, but it does not solve the fundamental problem of trust. Who is trusting whom? And this is nothing, in my opinion, AI can provide.
Yeah, I could add to that. I feel like it might be it's an indicator, but to me, it's still kind of reactive after the fact to be able to, detect these patterns and say that something is occurring, as opposed to what can we do to be more proactive from the beginning in terms of putting the right security controls in front of things, as opposed to just kind of waiting to see what happens. But definitely, I think more is better than less. So in terms of understanding patterns or changes in firmware, perhaps, detecting different bits and bytes and that sort of thing. So
that's a good point. That's the one thing is about prevention, and the second is about being reactive. But actually, when you have to be reactive, it's already too late.
Right. Yes.
Eventually the business continuity and how we make sure that our manufacturers to work. And then talking about that, I'm gonna smoothly go to the question that I have for you, Martin. So the machine outages, this is a problem that we have in manufacturing world. So what would be the top 3 machine outages cases by security features?
I think what we have seen in the past is, and the good thing is that we see more and more adoption of technologies around certificates and secure digital identities, topics like PKI and so on. That's good. However, very often those technologies are either not very well managed and certificates expire, and no one thought that this can happen, and you wake up one morning and figure out, oh, my whole production site is down because of one expired certificate. That's one scenario what we have seen already a lot of times. Another one is that still the technology and the machines can be become victims of a cyber attack because of the certificates and the security measures which have been done were pretty much poorly implemented. We have seen machines from one vendor where there's one and the same certificate for all of them, which was self-signed and created by using weak keys and so on. So the good thing is the secure identity is coming into the game. The bad is the bad is that they are sometimes, they can cause problems, number one, and number two, that they can cause outages if not managed properly.
Talking about certificates, I think this is coming very handy to the next question that I had for Alan. Why certificates? Why they are such a useful tool for IoT systems and devices?
Sure. Yeah. So I think there's been an evolution of use of keys and certificates over time, right? You know, starting even from like pre-shared keys and that sort of thing, and kind of where we are today in terms of best practice is use of asymmetric certificates as a way to establish a unique digital identity. So there's an element of you know, cryptography in here in terms of an encryption algorithm that is, you know, as strong as it can be so that it's hard to crack the code. And then also this sort of use of an asymmetric nature where you have you know, this sort of key exchange, you know, one that's publicly available, and then, you know, that's presented to be able to validate the other party and then create this secure connection. Like that's kind of how it works. And so very widely known technology within the enterprise of the IT, right? But then also we're starting to see that more and more moving over to the IoT and IIoT space. So it's very robust. And then I think as we in the cryptographic world improve on these algorithms and make them stronger and stronger, it really has been shown to be a solid way to protect endpoints. Okay, so that's again just a little bit from my perspective about why certificates are a good way to identify endpoints.
Okay, excellent. Thank you so much, Alan. I do have a couple more questions for you for this segment, but we do have a couple of questions in the chat. So would you like to take them within the segment, or should we leave them at the end of the session? How would you prefer? I think one is kind of going handy with what we talked. Tererai is asking, what is the ideal strategy or the most basic recovery option to machine outages? So this came towards the previous conversation point caused by a cyber attack. Eric, what do you think?
Yeah, I was just responding there in the text message there, but having robust backup and recovery policies and procedures in place is probably where you're going to want to start. And so not only just having those protocols in place, but are you practicing those? Do you actually know where your key controls are, where your key assets are? If they were to go, inoperable because of a cyber breach, how do you bring those back online? And so that's where your recovery procedures come into play, and you need to test those at least on an annual basis. And so whether those are through tabletop exercises where you test a few devices, or you can use it a little more of a red team or blue team approach, where you bring someone in to actually assess your environment where they could get in, and then it's remediation. Security is never there's not really a end state. It's a continuous improvement model from a security standpoint. But at your most basic level, backup and recovery procedures is your best bet.
Thank you so much. Thank you so much, Eric. We have another question. I'm gonna move back to our questions and then we can take it afterwards. If my panelists can check the question, feel free to prepare an answer for it. I would like to go back to Martin. Martin, we were talking about machine identities. So, and at the beginning of our conversation in the first segment, when we were talking about the risks, we talked about security by design, right? So why machine identities are so important for the security by design approach that we're trying to implement?
Yeah, that's a good question. I believe that trusted identities, this is a silver bullet to actually create a trusted infrastructure. Yeah, because we are talking about connected devices. We want that the machines can talk with each other, and we want to assure that the communication is confidential, and even more often, more important, it's that it cannot be manipulated. Yeah? And this can only be achieved if the receiver knows where the message is coming from, yeah, and the sender can prove that, hey, the message is coming from me. And this is a very very fundamental process also in human communication. And this PKI and trusted identity certificates, this is a technology how a trusted relationship can be established, and everything what we also talked about before, like code signing, this comes on top of that. So this is basically the fundament to establish all the other security paradigms on top of that. This includes also, I mean, we're talking about secure communication, code signing, authenticity, but specifically when we talk about systems which where actually the cash flow is out directly connected to operations like pay per process or pay per welding point or pay per hole. It's also very important that the data which is coming out from the machines, it can be proven that it's coming from the right source and hasn't been manipulated, because very often it goes directly into the billing system, and the operator has to prove that certain operations has been done. So this authenticity topics are very important.
Yeah, thank you so much. Ellen?
Yeah, I don't know that I have anything else to add to that. Other than maybe it's sort of an evolution in an architecture kind of conversation. Not every factory will be exactly the same, even within, you know, the same company. And it's going to change over time. So I think the concept is really around building something that can be scalable as your business changes. But, you know, is the most, you know, the most secure sort of way that you can set it up today, but then know that you're going to have to update that in the future, because, you know, the attacks that we are seeing, they change over time. The methods, the kind of ways that things are being, you know, attacked, or you know, it's not static. It's very much evolving. So you have to be able to adjust to that.
Mm-hmm.
Yeah, thank you so much. We have two questions on the line. I prefer to ask them and you respond to them live. But before moving forward, I do have one last question on the tool and technological side. We were talking about devices. So the next question that I have, Martin or Ellen, the device identities. So we would like to issue these device identities during the manufacturing process, right? This is a foundational aspect for the secure and trusted IoT business model. So what are the different approaches and how we can deal with this offshore production or offline factories? So what, Martin, maybe you can start.
Sure. I think in general, there are in total 3 options. Number one, this so-called birth certificate. This is how we call this initial secure identity of a device, are issued right in the factory, and the infrastructure, the IT infrastructure which is needed to do so, is also part of the factory IT, or it's basically in the same premises. And this is, of course, the advantage that it's independent from any internet connections. It's offline capable, so to say. If the internet goes down, the production still can continue. On the other side, of course, this requires that there's IT staff on site that can operate also this this part of the IT equipment. And suddenly there's this famous IT-OT gap. And this is a perfect example how this world needs to go hand in hand. So that's one option. Another option is that the secure identities, or the PKI, the public key infrastructure certificate authorities, are operated somewhere, either in the cloud or in the headquarters somewhere, not directly on the shop floor. And then this requires, and there are obviously solutions for that, that the production systems, ERP, MES, and so on, can talk to basically the PKI part. This again requires an internet connection. On the other side, it reduces the need for IT stuff being on-prem or on the shop floor. And the third one is where actually there is a process in place where the secure identities, there's a fundamental secure identity which is already injected during the manufacturing, but it's maybe not based on certificates, but for instance on symmetric keys. And there's a process in place where the devices retrieve the secure identity as a certificate, basically for the first time when they connect to the infrastructure, to the network, to the internet. It could be on field. So basically there are these three options.
Yep. Thank you so much. Ellen?
I think you did a great job of explaining those key options. I think just to keep in mind what we're talking about here is really the devices that are being produced in these smart factories, right? And so there's, as a manufacturer, as an OEM, you're responsible for then putting that initial identity in and putting the initial trusted firmware in, and then boxing up all of these things and then shipping them out to your customers. So it's also there's an element too of delivering a high quality product, which traditionally has been in the mechanical, electrical design, of course, but now there's also this high quality security component added into it as well. And so that's why we are talking about multiple ways to do this sort of in this kind of like zero trust manufacturing concept, because it's what your customers expect when you're delivering a high value connected product to them. It's just sort of expected that it has that layer of security. So I think that's where it kind of ties back to the business too, is we're selling these things for a higher dollar amount because they're supposed to bring additional benefits and values, and there's an expectation of very high quality around everything in terms of how it functions and as well as how secure it is.
Thank you so much. Thank you. Since we are still in the solutions tools technology, we do have 2 follow-up questions, so feel free to jump with the answers. Thank you so much, Deepak, for being active with us. So the first question: with the evolution of AI and machine learning technologies and the processing footprint it requires to execute the algorithm, where do you see this leads the edge device to? Certainly we do not want to run heavy CPU servers on the ground to help our AI algorithms. So we want smallest footprint and most impact. So what are your thoughts on this?
That's a great question, Deepak. I really would have to go back and kind of do a little bit of research specific to that. I don't know, Martin.
Yeah, I was hesitating to, I'm not an AI or ML expert at all, but I do hear what you're saying in terms of where can that function actually occur. So if there is some sort of gateway or data aggregator type layer, maybe that's where it happens now, until processing power, of the chips and components that could be, what is it, Moore's law, right? So that the smaller things get over time, that we can be more efficient. So I think that maybe that's what we have to do today, is just sort of place it at a different level within the stack until we can find some better solutions that are more directly on the edge. But that just makes sense.
Yeah, and there is actually a follow-up question. I think maybe this will help. Can you point us to some public library, available data libraries which can use to train the ML algorithms? For example, if I want to train my boiler and build predictive maintenance. So I think generally speaking, AI and machine learning, it's not only manufactured, generally speaking, it's still a developing field. So did you came across with some publicly available data that can be trained for ML algorithms?
I think, again, I'm also not an expert in AI and machine learning, but from that what I know, this is it's not about the library; it's actually about the learning data, and this is exactly what's where the magic sauce is, and this is very specific to the data which is used to learn, to learn, actually to teach an AI library. is very often subject to IP protection, and this is what a lot of companies protect, because this is the gold. Actually, it's not a library; it's a data to teach it.
Yeah, so I think that in the future we might see more of this as the systems and technologies become more available and people will be willing. But I think, in my opinion, if this will be the case, the people will keep it in-house for in-house knowledge. So until we get to the point that it would be shared. But I think this would be a good starting point, and eventually we'll get to the point that we'll have some public available data. But thank you so much, Deepak. Anything else that you would like to add from the panel in regards to the question, or generally about the segment, the tools, the technologies that we currently have to, as we mentioned before, diminishing risk and getting us to the level that we want?
I think there was an interesting question in the chat about using tokens and dongles to secure actually the operations of a machine. I think this type of tokens, specifically in the manufacturing environment, I mean, we're talking about an environment where robots move and there's a forklift that just is driving around and things like that. So hardware tokens can certainly secure or help securing software. On the other side, this is a perfect target for a DDoS attack. If this one is broken, someone runs against it, then the forklifter runs over it, the software, I suppose, stops to work. So I think this is a balance, and I think this brings up also a complete another dimension of this whole security discussion, which is related to physical security. How much can I trust actually the software which is operated in an insecure environment? Insecure because something can happen to it just by as an accident, or because I basically, me as a vendor, I'm using, for instance, a contracted manufacturer, and by definition, I mean, maybe I trust him in general that he's producing my equipment right, but he's handling my IP. How to protect that? And I think that's also and this very quickly relates to physical security, because there's some data is operated by software. The software runs on some hardware. The one who controls the hardware controls the data at the end of the day, unless I have thought the process completely through and protected against that.
Yeah, thank you so much. Thank you so much, Martin. So now we're right in time for our more or less a wrap-up segment, and we talked about the challenges, we talked about the tools. Now let's give some solutions for diminishing the risks as well as improving the productivity. So talking about solutions, Eric, back to you. When we look for solutions, security controls are key points when we talk about security in systems. Well, what should be considered when adopting new automation practices within the manufacturing world and IoT devices when we talk about the security controls?
Yeah, great question. So everybody gets hit up, by vendors and new tool providers, of things that are evolving in the world and in the space. And so very first, recommendation is get to know your security representatives. Who on your team is kind of leading this effort? What type of controls do they have in place? What type of policies, procedures do they have in place? Are you aware of that? Make sure you got that open line of communication so you know who's responsible for that, but also what is expected early in the design phases. You're starting to roll out more and more of these devices as part of a larger system. And so it's always easier to bake security in and wrap it in the 11th hour when resources are tight and deadlines are looming. So get to know your security team, follow their practices. That's first and foremost. There's several different controls, without going into like vendor specific recommendations, but network segmentation is really important. So consider segmenting your IoT devices, onto one or more dedicated networks to isolate that risk in the event they are compromised. They don't have that opportunity for lateral sprawl and for increased risk there. So minimize that. Look at access control mechanisms. So predefine your IP addresses. We've talked a lot about key management here. I think that's super important. Establish private and connections, whether those are private tunnels, VPNs, what have you, for really important data. embed certificates, like I said, you know, and we've talked quite a bit about, but just leverage your network access control, leverage your team, your security team to understand what's out there, what's already, you know, available to the environment is very important to know. And lastly, is just your visibility. Make sure you've got some sort of a tool out there or solution that is monitoring your choke points, your egress points, for example, you know, for different types of anomalous behavior, you know, and you can use new solutions that are looking at, you know, algorithms and new cloud-based, you know, data sourcing or crowdsourcing to get that type of information. There's a lot of threat, you know, open source threat intel that's available for IOCs or indicators of compromise. Leverage that type of thing to see what's going on in your environment. And then if you've got a team who can respond to those indicators and threats, you know, even better.
Yep, thank you so much. And talking about security controls as part of the solutions, now I'm gonna go back to Ellen and Martin. So we talked about all these things. So what should manufacturers do to establish this secure, solid IIoT security identity or the strategy? So we talked about security by design. So what should we do? What should they do?
Sure. So I would split it up into 3 key areas. So the first one being, I sort of understand and identify that the top level business drivers for your production environment, for your factory, or even for your company that can be impacted by this security, you know, initiative, and then design your system to support those goals. So understanding if it's just, you know, factory uptime, or it's, you know, quality of parts coming out, you know, low defects, like whatever that is, some component of that could be impacted by your security strategy that you're implementing. So make sure that's in line. That's the first thing. Secondly is to leverage proven tools. Some of the things that we talked about in the previous section around keys, key management certificates, code signing, like some of these things, you don't have to invent this for yourself. It's out there. It's kind of a building block that you can leverage. It's almost like security plumbing is one way to think about it. It's proven, and if you design it the right way, it works. So that's the second thing. And then the last thing would be, as you're architecting this system, make sure that it's flexible, because as I mentioned before, it's going to need to grow and change as technology changes, cryptography advances. We talk about quantum computing being able to come and kind of break some of the algorithms and the systems that we have today. So we have to be able to respond to that when it occurs. So know that you're not making something that's going to last forever, but it's the best that it can be right now, and then it has the ability to change.
Thank you so much. Martin, what should we do to have a strategy, a solid security strategy?
Yeah, there's not much to add to what Ellen already said from my side. I can just again recommend, do it early. Look into these topics as soon as possible. The longer you wait, the more expensive it gets. That's how it is. It sounds like security is very often a burden and a hassle, and also yeah, there's lack of specialists and experts in this area. Still, it's at the end of the day, and I think there are thousands of examples in the world why it is actually better to address it early, to ask for help, to reach out to experts in this area, involve them early in the product design, and it will pay out.
Thank you so much, Eric. Good practices, or what do you think?
In regards to good practices, you said? Sorry.
Good practices to establishing a solid security strategy for manufacturers?
Yeah, absolutely. So, I mean, it starts with kind of the MITRE ATT&CK framework. And so what are you doing to identify, detect, protect, respond, and recover? And so if you can walk through those and you have controls, you know, in place that can address all 5 of those areas, I think that's absolutely where, you know, foundational, you know, security programs should be.
Yeah, thank you so much. We do have a couple of minutes left, so I would like to open the floor for questions. If anyone in the audience has a question that we did not answer yet, feel free to do so. We have still a couple of minutes available here. So if you are posting your question, I'm going to ask our panelists. And meantime, are there any? Okay, so I was going to ask a question. We had a question coming from Boris. So Boris is asking, how about social behavior analysis? And this is a very good point, because one of my areas of interest is human link as the most critical link in security. So this is coming very handy with the social behavior analysis. So as a last round, as the time is kind of tight, so what do you think about it?
I'll just add on to what you just said there about, humans as the weakest link. And that's why we talk a lot about leveraging automation for some of these things, is because you can implement something, but then if it relies on one of us to be around and I, am on vacation or something like that, or I'm the only one who knows a certain process, you can relate that to any sort of thing. So I would say, yeah, trying to leverage ways to automatically update and to automatically check, and all of that is within our power to do now. So I think we should be leveraging that.
Yep. Yeah. Eric, Martin?
Yeah, I mean, I'm here in New York today, actually visiting with several different vendors, and actually heard from a couple of them, as a matter of fact, that are really focused on this type of problem. And so they're leveraging data sets from all over, whether it's social media, your habits online, what have you, to get a better perspective. So you're potentially easier target, to fish, for example. And so your online behavior and your social behavior is something that the adversary is really starting to pay attention to, because it gives them essentially a blueprint to have a higher likelihood of attacking you.
Yep. Martin?
Yeah, everything relevant has been said. Just thinking a little bit back, what was, I would say 10, 15 years ago in the IT environments or IT enterprises, very common were this security awareness trainings. What does it actually mean to actually training for the internal staff? How to detect if a mail is could be connected to a cyber attack? Should I click on the link? Yes, no. I think we down the road we will need to have also this awareness concepts expanded also on the shop floor and the machinery, because those again the stuff working there is usually not, the IT or in general, and specifically not IT security, is usually not their focus. So it requires a different type of awareness, and as you said, social engineering is a very common topic, and this is connected to many risks and the ability for cyber criminals to attack someone.
Thank you so much. I think we have one more question. So 2 more questions. So very quick response as we're wrapping up the session for today. So the first question is, if the OT cybersecurity is under the umbrella of the IT cyber protection? Really quick answer to that. So making sure that all the answers are, all the questions are answered.
Yeah, so this one's, it's kind of it depends, and I know no one likes that answer, but it kind of depends on what type of controls are in place on the IT side. As you look at security controls, typically your OT controls are protected, in your inner circle with multiple layers of protection. And so they're going to get the benefit of the IT controls. And so it really kind of depends on the maturity of the organization and what type of controls they have in place, how many layers they have in place. So.
Yep, I agree. It depends. Also, I mean, we've seen some practices where there's complete separation in kind of IT stuff that runs your business and then OT that runs your factory or the products. And that's intentional, right? So you don't have one vector coming in from one way and then impacting your production. So I think from like a networking standpoint too, that is sometimes a design decision.
Thank you. And the last question for today, is the OT network still prompt to ransom attacks?
Yes, absolutely.
No. Sorry, Eric, go ahead.
I would just, yes, simple yes, it absolutely is.
Yeah, and then
Martin?
probably I would even add we are probably just at the beginning. This will increase in the future. And for that reason, specifically the zero trust approach is very interesting, because it resolves to some extent the complexity which comes in maintaining an OT network, which can very often be also very complex. And usually also very often the IT stuff is very careful patching and changing it, because it sets immediate impact on the production process, and everyone, basically the main goal is always to avoid any outages in the production. So
And I'll just add, OT environments, computing environments are beginning to look more and more like IT computing environments. And so the risks that are in IT are translating to OT.
Yeah. Thank you so much. Thank you so much, my panelists. Again, Ellen, Martin, and Eric, thank you so much for those who watch our session today. This is concluding today's session. So please join the next session of the IoT Manufacturing 2022. Thank you so much, everyone.
thank you.
Okay.
Thank you.